Hello everybody, my name is Blake Holman and today I'm going to walk you through how neural networks are used for intrusion detection. So I'm going to give you a brief overview of what to expect in this presentation. So we're going to begin by going over what neural networks are and what intrusion detection is. So this is mainly for those of you who don't already have any background knowledge on neural networks or intrusion detection. Then we're going to go into what types of neural networks are currently used for intrusion detection. Then what data is currently used, as well as how this data is organized, and then we're going to end it with the accuracy of neural networks for intrusion detection. So we're going to start with introduction to neural networks, and I'm going to start by saying if you are interested in this subject, to do research on your own, because I do not have enough time in this presentation to fully cover what neural networks are capable of. So neural networks are also known as artificial neural networks, or ANNs, and this is a form of deep learning, which is a subcomponent of machine learning, which is a subcomponent in itself of artificial intelligence. So really what neural networks are is a model of how a brain works. So we have an input layer followed by a hidden layer or multiple hidden layers, and then an output layer. All of these layers can be variable sizes. So for the intrusion detection, some sort of network data will be used as input data. And this will be transferred into the hidden layer or hidden layers, which there will be some sort of computation that will produce the output. And this output will be whether or not there's intrusion on a network, or even what type of intrusion is occurring on a network. So even a more basic example would be a brain. So if you hear something, that would be the input data, what you're hearing, and then it will be transferred through neurons, which would be the hidden layer, until it comes to some sort of conclusion on what the sound is, which would be the output layer. So that is really just a basic explanation of what neural networks are. I highly recommend, if you're still confused, looking at other presentations to get a better grasp on what neural networks are. However, we do not have the time to get into that in this presentation, so we're going to move on to what intrusion detection is. So this is going to be a brief introduction to intrusion detection. So first of all, we need to understand what a network is, and so you can visualize your home network or even your work network to get a better understanding of how this all works. So on the right hand side of this slide, you can see that there's a wireless router connected to a desktop computer, a laptop, a printer, and a phone. Obviously, our networks, our home networks, our work networks are going to be a little bit more complex than this, with more devices and more interconnected devices with each other. So we need to understand also what intrusion is. So intrusion is when a hacker is trying to do some sort of attack on a network. So that could be a distributed denial of service attack, a denial of service attack, or even they're just trying to get onto your network to get free Wi-Fi. So our goal is to know when an attack is occurring and when it's not occurring. And so we have to have input data into our neural networks, as we discussed previously, and this input data is going to come in the form of PCAP files. So what a PCAP file is, it's a packet capture. And so on a network, you'll have devices that will send packets to and from the router, to and from other devices requesting certain information. During an attack, these PCAP files will look differently, and they will act differently, and they'll come in different forms. Either there'll be higher quantities of PCAP files from certain devices to other devices. So our goal is to input this PCAP file information into a neural network and determine whether or not an intrusion is occurring on a network. Now that we understand neural networks a little bit better and intrusion detection, let's talk about the types of neural networks that are commonly used for intrusion detection. So we start with a binary neural network. This is the image on the top right of the slide. So a binary neural network has an output size of 2, so it has 2 nodes in the output. And so basically Here what we are determining is if an intrusion is occurring or not. So we take the PCAP information, we put that in the input layer, it will transfer to the hidden layers, and we'll make some sort of calculation that will determine if an intrusion is occurring or not. Now let's say we want to determine what type of intrusion is occurring on a network, or if there is any at all occurring. We use a multi-class neural network. So this is similar to the image in the middle of the slide on the right hand side. So as you can see in the output layer, or layer 4 on the image, we have 4 output nodes rather than 2. So this can help us determine what type of attack is occurring. So we'll have PCAP information, we'll put it in layer 1, which is the input layer, and it will transfer through layer 2 and layer 3, which would be 2 hidden layers in this case, and then it will produce an output determining what type of intrusion is occurring. So both of the binary and multi-class neural networks take PCAP data, just standard PCAP data. However, a common type of neural network takes a sequence of data. So this PCAP data is actually transferred into usually a time-based sequence for a recurrent neural network. So you take this sequence and you put it into the input layer, and it will transfer through the hidden layers, and it will remember some of the sequence, and then it will produce an output based on the sequence of information. So if an intrusion is occurring, over time it will be able to tell that an intrusion is occurring and output the correct answer. Or if intrusion is not occurring, it will also be able to tell that, or potentially even what type of intrusion is occurring. So that is how recurrent neural networks differ from binary and multi-class neural networks. And there's an image on the bottom right of this slide that shows a diagram of what a recurrent neural network can look like. So a recurrent neural network can act as a binary and multi-class neural network, however the input data is just slightly different, and the hidden layers act slightly different because they remember some of the sequences that are input. So now that we know what types of neural networks are used for intrusion detection, let's talk about what data is used. So we already talked about how PCAP files are largely used for the input for neural networks when used for intrusion detection, but what does this information contain? On the image to the right, this shows you what type of features can be extracted from a PCAP file. This contains the source IP, destination IP, protocol type, and the length of the packet, as well as some other information. So what information is used depends on what neural network is used. So for example, when you have a binary neural network, you'll typically use PCAP information from a normal neural network and a single type of intrusion. When a multi-class neural network is used, you usually use PCAP information from a normal neural network as well as multiple networks containing different types of intrusion. All of this information is typically stored in some kind of data set or database that is then input into the input layer of the neural network. Now let's move on to how the data can be organized. So the PCAP data can be organized in several different ways. First, and one of the most common, is just using the PCAP features and inputting different features from when an intrusion is occurring on a network versus when intrusion is not occurring on a network. However, there's some more advanced methods that are used for intrusion detection, such as clustering and self-organizing maps. Clustering is the idea that you take normal network activity and you cluster that together, and then when an intrusion is occurring, you cluster that information together, and this gives you a better idea of when intrusion is happening on a network. The last method is using network traffic flows. Now, network traffic flows are the flow of packets between one device to another on a network. So this will be monitored during a normal network activity. Then, during an intrusion, there could be abnormal activity by either more or less packets being sent from a device to another device. Or even a hacker could get their device on a network, and this would be able to determine that there's a new device on the network and blacklist it from the network, and it will help with intrusion detection. Obviously, it is very important for the neural network to have a high accuracy for intrusion detection. So between two neural networks that we've discussed, binary and multi-class, binary neural networks actually have the higher accuracy rate. This is because they're just trying to determine whether or not there's an intrusion on a network, whereas multi-class are trying to determine what type of intrusion is occurring, or if there is one at all. So obviously there is more error in a multi-class neural network. However, they're both still relatively accurate. Between other methods of intrusion detection and neural networks actually have the highest accuracy rate of any other intrusion detection method, including J48, random forcing, support vector machines, and many more. And this is true for both binary and multi-class classifications of intrusion detection. The use of neural networks for intrusion detection is a very new and promising field. I encourage you to look into it more if you are interested in the subject or if you like this presentation. Thank you for listening, and if you have any questions, please leave it in the comment section and I will try to answer them as quickly as possible. Thank you.